Hi students, how are you? Fine. Let us start today's class. Chapter 1, Area. Now look on this board. You can see triangle ABC. Which are the vertices of this triangle? A, B and C. Can you see a perpendicular from the vertex A to its opposite side BC? What about its length? It is of length h. Here base is marked as B. That is, length of BC is B and perpendicular from its opposite vertex is of length h. What about area of this triangle? You already know, if base and height are given, area of the triangle is, that is, area is half BH. Now listen, you can see three lines, AB, PQ and DE. What is special about all these three line segments? They are of equal length. What about length of these line segments? AB is of length B, PQ is of length B, DE is of length B. Now going to mark, here you can see a point M on AB and a point N on PQ, a point O on DE. Here on these 3 points, I have drawn perpendicular lines, perpendicular to the below line. That is, CM is perpendicular to AB, RN is perpendicular to PQ, FO is perpendicular to DE. Now, I am going to join CA and CB. You can see a triangle ABC. Now, I am going to join R to P and R to Q. You can see a triangle PQR. Now, I am going to join DF and FE. You can see a triangle DEF. Can you give me the area of this triangle? What about area of this triangle ABC? You can see area is half BH. Area is half BH. Now look on this triangle. How will you find area of this triangle? You know, area of any triangle is half into base into height. Here also base is B and height is h. So area is half into B into h. Now listen to this triangle DEF. What about its base? B. What about its height? H. Now how will you find area? Area is half into base into height. That is, you can see for all these three triangles, their areas are same. Why their areas are same? Because each of these triangles are having same base. That is, their bases are equal and distance from opposite to vertex to that bases are also equal. The distance from opposite vertex to this base is h. Height from opposite vertex to that base is h. Height from opposite vertex to that base is h. That is, if base and height are equal, then the triangles are of equal area. Here you can see these three triangles are not equal. Their sides are different, their angles are different. But one side is common. Which side is common? For the three triangles AB, PQ and DE are equal, but other sides are not equal. But you can see one thing, it is that height from opposite vertex to the base is common to all these triangles. That is, triangles having same base and height are of equal area. Now listen to the board. You can see a rectangle ABCD. Here length of the rectangle is B. Breadth of the rectangle is H. Then what will be the area of this rectangle? You know, area of a rectangle is length into breadth. That is, area of rectangle ABCD is equal to B into H. Now, I'm going to mark a point E on the side CD. Then I join A and E. Then I join E to B. Now you can see a triangle ABE. Can you find area of this triangle ABE? Here base is given. What about base? Base is B. But height is not given. But we can find it. How will you find it? You just draw the perpendicular from E to the base. What about length of this height? It will be H. So we got the height of this triangle ABE having base AB is H. Now you know area of this triangle will be half into base into altitude. That is, area of triangle ABE is half into B into H. Now you can see whenever we draw a rectangle like this, taking a side as base and a point on opposite side as third vertex, if we draw a triangle, that triangle will be of area half the area of the rectangle. That is, area of this triangle is half the area of this rectangle. Now I am going to mark some more points on this side, F and G. As earlier, joining A to F and B to F, G to A and G to B. Here you can see three triangles. One is the earlier one ABE, other is ABF, last one is ABG. We can draw many triangles like this. Can you give me areas of the last two triangles that we drawn? What about area of ABF? You know, for all these three triangles, they are having same base. Here also, the height of all these three triangles will be equal. Each is having height h. That is, area of triangle ABE equals area of triangle ABF equals area of triangle ABG. Similarly, we can draw many triangles in this rectangle having same area. Why areas of these triangles are equal? They all are having equal base. Their base is common and their heights from opposite vertex to that side is equal. If base and height are equal, then areas also will be equal. And area of each of this triangle will be half the area of the rectangle. Now listen, why the heights are same? Because we take the third vertices on the same line, and that line CD is parallel to AB. You know, between parallel lines, the distances are same. Distances are same. Listen, can you see these two parallel lines? That is, this line passes through A and B. Some points on this line are F, C, D, E and G. These two lines are parallel. Now I'm going to join D to A and D to B. Yes, we got the triangle ABD. Base of this triangle is AB. Now I'm going to draw the perpendicular from D to this base AB. I have drawn the perpendicular from D to the base AB and taken its length as h. That is, area this triangle is having base B and height h. Then area of this triangle will be half into B into h. That is, area of this triangle ABD is half into B into h. Now I'm going to join F to A and F to B, C to A and C to B, E to A and E to B, G to A and G to B. We are getting triangles ABF, ABC, ABE and ABG. What is special about all these triangles? They all are having equal base AB and is having length B. Now what about heights from F to AB, C to AB, D to AB, E to AB and G to AB? You can see heights from each of these points to the line AB is same and is equal to h. Why? These two lines are parallel. In between two parallel lines, the distance between is always same. That is, all these triangles are having same base and same height. That is, area of triangle ABF is half BH, area of triangle ABC is half BH, area of triangle ABD is half BH, area of triangle ABE is half BH, area of triangle ABG is half BH. From today's activity, we can come into a conclusion. That is, in between two parallel lines, areas of triangles having same base are of equal area. Now, let us consider some problems related to today's learning activity. Here, first problem is, these two lines are parallel. Can you find a triangle which is of equal area of the triangle ABE? Try to find. The answer is triangle ABF. Why? Triangle ABE and triangle ABF are having same base AB and they are in between two parallel lines. We know triangles having same base in between two parallel lines are of equal area. Now look on this problem. Here you are given a rectangle ABCD. Length of this rectangle is 10 centimeter. Breadth of this rectangle is 6 centimeter. Question is, what is the area of this rectangle? What is the area of this triangle ABE? What is the sum of areas of triangle ADE and triangle BCE? Now let us consider the answer. area of rectangle ABCD is 10 into 6, 60 centimeter square. Now, area of triangle ABE is half into 10 into base, half into base into altitude. Here base is 10, altitude is 6. So, area of triangle ABE is half into 10 into 6, that is half into 60, 30 centimeter square. Now let us consider answer for the last question. Last question is to find sum of areas of triangle ADE and triangle BCE. You know, sum of areas of triangle ADE and triangle BCE is as same as area of rectangle ABCD minus area of triangle ABE, that is 60 centimeter square minus 30 centimeter square equals 30 centimeter square. I think almost all of you understand today's learning activity and are able to solve the problems related to this activity. Thank you for watching this video. See you again.